Okay, so we have basically the law of sines for two triangles. We start with one and we see we have another triangle with the side angle triangle. So we're given two sides and one angle. B equals 75 centimeters, which is one side. Side C is 90 centimeters, and angle B is 25 degrees. So let's go ahead and start. So what we want to do is basically draw a triangle and label it. It doesn't have to be perfect. I mean, I don't really care if it's perfect. I just want to get straight to the point, so it doesn't matter with matching up these sides anyways. You could if you want, but we're going to skip that for now, and we're just going to go ahead and start with a random triangle. So I'm going to pause and come back with a triangle, all right? So this is some random triangle, an equilateral or whatever that we drew. So let's label this point capital A, this point right here capital B, this point right here capital C. Okay, so this point right here will be lowercase a, this point up here will be lowercase b, this point up here will be lowercase c, little c or whatever. So that's what we have. This is our basically our format that we're gonna work with. You can rearrange it however you want. Just make sure the A is like mirrored. The little a is mirrored with the B. I mean the A, and the little b is mirrored with the big B, and the lowercase c is mirrored with the uppercase C. Just make sure it's like it follows this pattern. Doesn't really matter how you do it, but just make sure it, they're together like that, like so. Okay. So now we can go ahead and plug in our values, which B is going to be 75 centimeters. So B, let's go ahead and label 75 centimeters. C, I don't know if this pen is too thick, but I guess I'm just going to work with it. C is equal to 90 centimeters. So let's just put 90 centimeters. 90 centimeters. And A, they didn't give us A, so we're gonna look for A. We're gonna find A. But they did give us angle B, which is 25 degrees. So this is B right here, and our angle is gonna be 25 degrees. Good. B, angle B is 25 degrees. So now our law of sines. Let us do the law of sines now. So we have sine of B, because that's pretty much the only angle we have. Sine of B, sine of 25 degrees, over B, little b, which is 75, over little b, is equal to, let's just say, sine of C over little c, lowercase c. So that's basically the basic formula. You can use it for whichever point you want, just as long as you have at least either the angle or the side. You'll see what I mean when we go over this example, so let's go ahead and do it right now. But that's just a general idea of it, all right? Let's go ahead and do it right now. So we have sine of B, which is the only angle we have, so that's the only sine we can take right now, sine of B, right? So sine of B, sine of 25 degrees over B, little b, 75 centimeters, right? 75. So hope you're following along. Sine of B, which is the only angle we have to work with, is 25. Sine of B is sine of 25 degrees over B, little b, which is 75. All right, is equal to, since A doesn't really have a side length to work with, we're only left with C. So C does have a side length to work with, but it doesn't have an angle. Let's go ahead and find the angle by basically just labeling this sine of C. Sine of C, good. And this is going to be, what is a little c? It's 90 centimeters, right? So it's going to be over 90. So now what is left to do is basically just solve. We're going to solve for it. So how are we going to do this? We want to leave sine of C alone. So let's just go ahead and do a little bit of basic algebra. Multiply by 90 on both sides, right? These two, 90 and 90, cancel out. So now we're left with sine of C is equal to 90 times sine of 25 degrees over 75. So let's go ahead and approximate that using our calculator. So so 90 times sine of 25 degrees equals 38.08 divided by 75, right? That's going to give us that. So now that you have this value, you are going to take the inverse of your value, of your answer, right? So sine inverse of your answer, whatever answer you got, in this case 0.57 and so on and so forth, answer is going to give you your angle. So let's go ahead and do that right now with the calculator. Inverse sine, shift, inverse sine, where is it? Right? Of our answer we got is equal to 30.4 whatever. In this case, we're just for the sake of this example, we're just going to say 30 degrees. You know, we're just going to keep it at whole number. So roughly equals to 30 degrees, right? So that is going to be basically angle C. So let's just write it here. Angle C1, because there's going to be another angle, and we'll see. There's going to be another triangle, and we'll see in just a bit. Is roughly equal to 30 degrees. So that's one of your answers. Let's go ahead and box that. So since this is a side angle triangle, chances are we're going to have a second triangle. So how do we find that second triangle? Well, yeah, second angle in this case. We're going to basically take 180 degrees. If you didn't already know, in a triangle, all of these angles, all three angles have to equal to 180. So let's go ahead and take 180 minus 30 degrees, which is going to give you, I believe, 150 degrees. 180, yeah, 150 degrees. So that's going to be your angle number C2. Angle C2 is equal to 150 degrees. Because we found another angle just by subtracting 30 by 180. All right, so we're all clear on where I got this second angle, right? This first angle, we already did the law of sines, inverse sine answer, 30 degrees. This second angle, we got it by basically just taking 180 and subtracting 30 degrees to get, 30 degrees, which is angle C1. We subtract 180 from this. Well, we subtract this from 180 to get 150 degrees, right? We have angle C2 equals 150 degrees. Again, we subtract, just take 180, subtract whatever you got here, and you get your second angle of the second triangle, C2. So now we found out that we do have a second triangle. So let's go ahead and just draw this second triangle. Again, it does not have to be perfect. Just draw any random triangle, doesn't really matter. I just like keeping it an equilateral triangle because it's easy. So now let's go ahead and label it as let's just label it in the same manner as we did here, just not to get confused. So A2, B sub 2, and C sub 2. Cool? So now that we have our second triangle, let's plug in the values already given to us in the second triangle. So 90 is already given to us, so that's not going to change. So we're going to have to put 90 right here, 90 centimeters for the little C2, right? There's big C2, and that's little C2. Big C2, little C2. Big A2, little A2. Big B2, little B2. Good? So now our B is 75 centimeters. So again, we're going to plug it in B, the little b sub 2. 75 centimeters right here. because it's already given to us. We're not going to change it. And this, we're obviously not going to change 25 degrees. So we already have our C2, which is 150 degrees. So let's just go ahead and plug it in right here, 150 degrees. Cool. All right, so we have C1 and C2. So let's go ahead and find our angle A and angle A2. Let's go ahead and do that. So let's go ahead and label it right here too, 30 degrees. All right, cool. Now we're good. Now we're up to date. All right, we're good now. Okay, so angle A, recall what I said. All the angles in a triangle have to equal to 180. All right, all the angles in a triangle have to equal to 180. So in order to find angle A, we just basically just take 180 and subtract these two angles from it. Let's go ahead and do that right now. 180 minus 25 degrees minus 30 degrees. That's going to give us 125 degrees. That's going to be for our first triangle right here, because we got 180 and we subtracted these 2 degrees to get 125, right? So our angle A is going to be 125 degrees. 125 degrees. All right, let's go ahead and label it right here. So angle A1 equal, doesn't really matter, roughly equal, whatever. Let's just, you get the point, 25 degrees. Cool. So now we have that for angle A1 equals to 125 degrees. Let's go ahead and do the same thing for angle A2 right here. Basically just take 180 and subtract these two angles. Let's go ahead and do that. 180 minus 25 minus 150, right? 150. This is going to be for the second triangle. We have 5 degrees. So angle A2 is going to be 5 degrees. Let's label it right here. Let's just label it right here. Angle A2 is equal to 5 degrees. This would be an approximation, but just for the sake of this example, we're just saying it's equal to. Doesn't matter. Let's just keep it at whole numbers just to keep it simple and straight to the point. All right, so now we're done with finding our angles. We found all 3 angles, but we're missing the little a. A right here, little a and little a sub 2. A, little lowercase a sub 2. Let's find that. So let's use the law of sines again to find the little a. So let's go ahead and just basically use what we were already given. Angle B is 25 degrees. Little b is 75 centimeters. Let's just go ahead and use that just to keep it simple. Since it's already given to us, we can assume it's true. So let's just go ahead and use that one. All right. Let's avoid using, these like C, because those are the 30 degrees is values are approximations, values we calculated. So let's go ahead and just use the stuff that's already given to us, that's already true. So angle B, sine of B. Sine of B, if you remember, is angle B is 25 degrees. Over the little b, we're doing this for the first triangle, by the way, the first triangle. And then we'll do it for the second one, all right? So B and little b is 75 centimeters. Cool. B over little b. So B is 75 centimeters. Again, just follow the equation. Just follow the equation, and that's it. Let's go ahead and find little a now. Equals to little a. So we have 125. We put the angle A, sine of 125, over little a, okay? Sine of 125, just following the equation, sine of whatever angle over the side. In this case, it's little a, just 1, okay? Lowercase a, whatever it's called. All right, cool. So now we have sine of 25 degrees over 75 equals to sine of 125 degrees over a. So now we just do a little bit of algebra and just solve for a. And so let's just go ahead and do that right now. If you don't know algebra, then I'm just going to go ahead and walk through it. But if you already know algebra, just skip or whatever. So a, let's multiply a by both sides on this. cancels each other out. We have a sine of 25 degrees over 75 is equal to a sine of 125 degrees. So now let's go ahead and multiply 75 by both sides. Now we have a sine of 25 degrees equals to 75 times the sine of 125 degrees. Let's go ahead and divide the sine of 25 just to leave a alone. This is just basic algebra, it's alright. Sine of 25 degrees. Okay, so now we can just plug this all into the calculator to solve for a. So let's go ahead and do that right now. This is going to be tedious, but let's go ahead and do this. So 75 times sine of 120, right? Sine of 125, sorry about that, equals, that, divided by sine of 25. Divided by sine of 25. Let's just keep it at whole numbers. This is going to give us 145 centimeters. Keeping it at whole numbers equals to 145 centimeters. So let's go ahead and just write it right here. Little a, lowercase a sub 1 is equal to 145 centimeters. Cool. So this is, we already found little a, 145 centimeters. So now let's go ahead and find out a sub 2, little lowercase a sub 2 in the second triangle. Same process. You know what? I'm just going to show it to you, but it's the same process. If you don't want to watch it, just skip to the end. And yeah, but it's the same process. I'm just going to show it to you. So, again, use what's already been given to us, which is 25 degrees and 75 centimeters. Let's just use that, you know. Don't complicate things on yourself. So, sine of 25 degrees divided by 75 centimeters is equal to, we're gonna look for the lowercase a sub 2, which is, again, sine, follow the formula, sine of, you guessed it, 5 degrees, because we're looking at a right now. Sine of 5 degrees is equal to, divided by a 2. Again, solve for a, leave a alone, blah blah algebra. I'm assuming if you're watching this video, you already know algebra. So, but for those who don't, which I don't know why you're watching this, but whatever, I'm just going to go ahead and do it for you. Same process we did right here. Again, multiply by both sides. We have a sine of 25 degrees over 75 equals to sine of 5 degrees. Multiply both sides by 75. Remember what you do to one side, you do to the other side. A sine of 25 degrees is equal to 75 times the sine of 5 degrees, right? And then we divide the sine 25 degrees from both sides. Cancel each other out, so we just have a by itself. Sine 25 degrees. Now, just plug it into your calculator and let's see what a sub 2 is roughly equal to. Okay, remember, calculator is just an approximation. So that's why we put the little squiggly lines, because it's just an approximation. So we have a 75, right, times sine of 5 degrees. It's going to give us that thing divided by the sine of 25 degrees. And that's going to give us 15.4, blah, blah, yeah. Let's just keep it at whole numbers, just for the sake of this example. So it's going to be 15 centimeters. Cool. Little a sub 2 is equal to 15 centimeters. And that's pretty much our last and final answer. So we have let's go, 15 centimeters. So, yep, that's basically it, you know. We have 1, 2, 3, 4, 5, 6. We have 6 answers. We got it all down, you know. This stuff is easy, basic trig. You know, you got this, you know, it's easy, all right? That's it. Nope. Basic algebra, trig, good for calculus. Good for calculus. Yeah, get you ready for calculus. All right, good. So yeah, that's it. Good luck.